In this video, we'll apply the first step of the structured approach to estimating energy savings to energy conservation measures within compressed air systems. We'll look at how you can assess available data from your compressed air systems to inform your approach to estimating savings and provide confidence that your savings estimates are grounded in reality. You should start by collecting information about your compressed air system. It's important to identify the type of compressor you have and its control system. Compressors can be rotary screw, reciprocating, centrifugal, or other types. Control systems can include on-off, load-unload, or variable speed drive. If you have multiple compressors, you should determine if they're sequenced using cascade pressure control or a master controller. This foundational knowledge of your system is critical to understanding how your system will respond to operational changes and prevents you from using assumptions that don't apply to your particular system. When it comes to compressed air systems, the most common reason for inaccurate savings estimates is using calculations or a rule of thumb that doesn't apply to your type of system or controls. If you're not sure what type of compressor or control system you have, the best place to look is on the compressor nameplate to get the manufacturer and model number. The nameplate can also provide information on compressor power rating and capacity. You can use the manufacturer and model number to look up the type of compressor and control system, as well as its Compressed Air and Gas Institute reference sheet, or KG sheet. This will provide detailed performance information and typical characteristic curves that show the percentage of power used as a function of compressor loading. These curves are useful in understanding how the power consumption of your compressor responds to reductions in flow. For example, a screw compressor with variable speed control will reduce power almost in proportion to the reduction in flow. Meanwhile, a screw compressor with inlet modulation will continue to operate near its full power even when flow is reduced. Once you've collected data on your compressed air system, you'll need to assess what operating data are available. In particular, you'll want to look for energy consumption data, either compressor power or current draw, discharge pressure, and compressed air flow rate. Having this information logged at 5 or 15-second intervals will make it easy to establish an accurate baseline. If you do not have logged data, you should assess what other information is available to understand your compressor's operating profile. Some compressors may have the ability to measure power, pressure, and flow, but require an external system to log the data. Some compressors may keep a running count of loaded and unloaded hours, which can be used to calculate the ratio of time spent loaded to time spent unloaded. With this information, you can determine if you need to fill in any data gaps. If you need highly accurate estimates and don't have logged data, you may want to install some data loggers to measure power, pressure, and flow at 5-second intervals. If you don't need highly accurate data, then using the KG sheets and available data on your operating profile may be sufficient. Your next step is to establish an energy consumption baseline.